Good morning, everybody. Today I am going to discuss the thermodynamical parameter. Important thing I want to share you, because whenever I discuss thermodynamics or quantum mechanics, I will merge one or two subjects. Because apart from typical classroom study, what I am going to do, whenever we study quantum mechanics, you don't study only quantum mechanics. So you merge statistics, physics with quantum mechanics. What I mean that whenever you do a problem, over that same problem, you try to find out various thermodynamical parameter as well as apart from quantum mechanical parameter. For example, every mean energy. Mean energy also we have found in statistics, physics, also in quantum mechanics. What is the basic difference? If you see that formula, you will find the similarity. All formulas are same. If we remember the formula, mean energy formula in quantum mechanics, you can remember the same formula you can apply in statistical physics. Okay, and that is why I merge one or two subjects. I will give you the formula as well as all the numerical problem whatever asked in the exam, and what are the possible questions that often asked in the exam. I will also discuss. I will go slowly, and another important thing, I am going to strictly follow Pathria book. It is I have taken from the all the numerical, all the theory related to statistical physics from Pathria book itself. Today I am going to discuss the chapter number 3, which is very important from the exam point of view. Okay, and I want to merge one or two subjects. Apart from typical classroom study, I merge statistical physics with quantum mechanics. Okay, in next 2-3 video, I will merge condensed matter physics with semiconductor device. Whenever I teach particle physics, I will merge with classical mechanics. This way, whenever I teach you the electrodynamics, I will merge with mathematical physics. This way, I will merge all the subjects, and I will give you the tricks how to study physics. Okay, then you can easily understand. So today I am going most important parameter, and this is how important. I am not highlighting myself. I am telling these things only to promote you, so that you can, I do believe that, so that you can qualify the all net gate exam. And I do believe that you can easily qualify. This net gate exam is not so hard exam. It is very simple exam and basic level exam. If you have a basic concept, you can easily complete your question paper, as well as you can easily understand the numerical problem whatever given in the exam. Okay, that's why I focus on basic things, then I will go to the numerical. Okay, after finishing this chapter or finishing the thermodynamical parameter, I will also go to various numerical problem that I did. Okay, I have derived all possible questions which may be asked in exam. Okay, and it is definitely come from that portion, because I have derived all the new question, all possible question from a particular topic. Okay, and I will going to teach you how to study. So today I am going to discuss probability theory. Probability. See, you have already learned the probability in quantum mechanics. You have learned also probability in mathematical physics. You have to learn probability theory in statistical physics. What is the basic difference? So in mathematics, probability we write like this: probability. You have already know. In statistics, total number given. Suppose you can understand laser physics. This is in laser physics. 2 energy level, n1 particle, 2 particle. n1 particle plus n2 particle is n particle. Suppose you can understand from laser point of view. Suppose you have a two level laser system, and total number of particles is n, and which is distributed between 2 energy level n1 and n2. Then what is the probability of finding particle in n2 state? Is very simple. In n2 state is this one, n1 plus n2, this state. Okay, and n1 state, that is 2 state. P1 state is simple, n1 plus n2 equal to n1. This is in mathematics. Okay. This is in mathematics. See, probability, I am again telling you, probability formula is always use Always remember, probability is the fraction of particle. This is the total number of particle, and it is the number of particle occupied in a particular level. And it is always represented by the function, mathematical function, which is in Fermi statistics, it is called Fermi function. Fermi function is the probability, occupation number. It will give a probability of finding particle in particular region. In mathematics, we represent, that is in quantum mechanics. In quantum mechanics, how we represent? Quantum mechanics probability is written like this. I have shown in the last class. That is in quantum mechanics. Okay. And what is the view in statistical physics? Statistical physics, this is statistics. Statistics, it is represented as in terms of energy, sum of e to the power minus beta ER, e to the power minus beta ER. Okay. This is a general formula. Probability in statistical physics, probability in quantum mechanics, probability in mathematical physics. Okay. This is the basic difference. So I will discuss first this part. So what do you mean by that? Probability P, E, N, or you can write N also, no problem. This formula is normally GR e to the power minus beta ER sum of GR e to the power minus beta ER. Okay. But previous formula I have shown you, I have not put GR. GR is the degeneracy factor. Normally what happens, if the system is non-degenerate, degeneracy is GR equal to 1, then we always represent probability formula like that. For better, for simplified version. This is simplified version for non-degenerate system. Beta ER. Always remember, this is the probability formula in non-degenerate system. This is the probability formula in degenerate problem. Okay, what is degeneracy and what is non-degeneracy? I will tell you. Degeneracy we have also know in quantum mechanics, and degeneracy also know in statistical physics, atomic physics, and molecular physics also. We'll discuss, and you will understand easily whenever I do numerical. Okay, you just remember this is the probability formula, and this is first thing. Probability formula, and second is a partition function. Partition function. What is a partition function? Partition function. This is known as a partition function. Partition function. E to the power minus beta. So first of all, I will discuss two parts. One is probability and one is partition function. Then you will understand easily. So this is partition function, and after that, I will give the general formula. Then you can easily understand. So, first of all, we will do one numerical. Then you will understand. Okay? Consider a system. I will not write the consider a system of n spin half particle. Spin half particle. Okay? And each particle can stay in two different states. And each particle can have into another level E1 and E2. Okay. E1 and E2. Where E1 and E2 are magnetic energy. Okay. So you try to understand. Consider a system of n particle, spin half particle, all particle are non-interactive. Okay. And each particle can have two energy state. That means each particle can stay E1 energy state, E2 energy state. Okay. Now question is that what is the probability of finding particle in each individual state? How can we evaluate it? Okay. And all the state are non-degenerate. Again, I am telling you one condition: all the state are non-degenerate. Now my point is that how to calculate partition function and probability. This is the main point. So I have the question I will discuss. So solution. So we know the probability formula. You better write down the formula, then you can, because this is a non-degenerate system. The non-degenerate system means its level have degeneracy 1. And these are, I want to tell you what do you mean by the degeneracy according to quantum mechanical point of view. If a quantum mechanical state, quantum mechanical system have common energy but different wave function. Suppose different wave function means different, it can stay in different state. Suppose me, I am Anil Hazarika. Okay, I have a constant, suppose energy. Energy means, energy is a characteristic parameter which defines the particle. So Anil Hazarika, energy, I have a fixed amount of energy. I can stay in Guwahati, I can stay Tezpur, I can stay in Jorhat. So whenever I stay in Guwahati, my representation or wave function will be different. But I am the same person. I can stay Guwahati, Tezpur. This is called degeneracy. A system have different orientation or different wave function representation, but they have common energy. Energy is same, wave function is different. So I will discuss the degeneracy whenever I encounter the particle in 3-dimensional box. And one thing is, remember, degeneracy exists only isotopic body. Isotopic body means, suppose if you consider cube, if the cube is symmetry means x is equal to y is equal to z, then there will be degeneracy. Suppose particle in 3D box, it will be degeneracy only when it is a equal to b equal to c. That means all dimensional shape. Okay, if there is no symmetry, then there is no degeneracy. And one-dimensional problem, there is no degeneracy. Always remember. So in that case, I will write the formula. This is the formula. E to the power beta ER, sum of e to the power beta ER. Okay, this sum means all possible state. Here, what is the possible state? 2 energy, E1 and E2. If there is a 3 energy, then it will be goes like this. Okay, first probability in this state, E1 state equal to how much according to this formula. Okay, e to the power minus beta E1, e to the power minus beta E1 plus e to the power minus beta E2. This is the first probability. Or you can say, if you divide this numerator by this value, then it will be 1. Suppose if I divide this e to the power minus beta ER, we have to divide all the term, na? E1 and e to the power minus beta E1. Then what happened? 1 plus e to the power minus beta E2 minus E1. 1. In exam, what happened? In exam, NET exam, so question answer will be optional. But you may not find this type of formula. Okay, you may not find this type of answer in the answer sheet. So exact answer is this one. But in NET question paper, if you cannot find this answer, so you will find this type of answer. And sometimes they will mention also hints about E2 minus E1 equal to del. Sometimes they written like this. So they want to make the question more complicated, and they want to ensure whether you understood or not. In that case, this is a probability 1 plus e to the power minus beta del. Yeah. This way you have to understand. Okay. That is probability in first state. And similarly, probability in second state, E2 state is simple. Only this formula beta E2 and 1 e to the power minus beta E1 plus e to the power minus beta E2. Then you can divide also. It will be 1 plus divide numerator by numerator. Then it will be 1. It will be 1 plus e to the power minus beta E1 minus E2. Okay. Or you can, according to this formula, then you can express as a 1 plus e to the power beta delta. This is the probability. Okay, but total probability P E1 plus P E2, if you add up, it must be equal to 1. If it is not equal to 1, that means your answer is wrong. Okay, you can verify yourself. Now, this is the basic theory. Okay, same problem I will modify. Question is same, but I will modify simple part where E1 same question I will modify. You see the answer will be different. When E1 is doubly degenerate, and E2 is non-degenerate. Okay, that means now answer will be different. Same question, answer will be different. So you have to see. That is why we have to understand the basic concept. Once you understand the basic concept, if somebody changes the question, you can easily change your answer according to the question. That is why it is important. So I will simplify the problem. This is suppose n particle system. All particles are spin half n particle, and each particle has two energy level, E1 energy and E2 energy. Okay, and E2 energy is doubly degenerate. This is the simplified in mathematical. Again, I am telling, consider a system of n particles. All are electron, spin half particle, fermion, electron may not be electron, fermion, and its particle have two states, two energy level. One E1 and another is E2. All are magnetic energy. Okay, and E2 energy is doubly degenerate. So what is the probability of finding the particle in E1 state and as well as E2 state? Now you see the question. And another hint they have in the given question is given E2 minus E1 is equal to that. So I will change the question. So I have written now general formula. See carefully. This is initially I have written this formula. Beta here, sum of GR minus beta here. Okay, this is the formula of probability in case of a degenerate system. Same formula you can remember. When system is non-degenerate, then GR equal to 1, we can remove the GR. It will be similar to the previous formula. But now the question is E2 is degenerate. Degenerate means system is degenerate. You have to recall the degenerate formula. So what is the degeneracy formula? Now I have to find out the probability in E1 state. So how can you find out is C? I have to E1 state. Whenever you encounter E1 state, this is favorable event. Favorable event, it must be in upper. How can you remember? This is probability. I am again telling. Probability in total event, and favorable event. You know this definition. This is simple definition. Probability is favorable event divided by total event. So if you confuse, then you remember whenever I try to find out the probability in particular E1 energy state, this must be in the numerator. But if you forget, then you remember this formula. Favorable part must be in the numerator, and denominator is a total event. So it is because of this reason it is written summation. Summation means sum of all the steps. It will give the total number of steps. Okay. Now I have to E1 state is non-degenerate, E2 state is degenerate. Because I am going to find out probability of E1 state, then it will be G1 equal to 1 e to the power minus beta E1. Remember, this is summation means all possible states. Here there is two states, we will have two number. First one is 1 e to the power minus beta E1. Okay. Next, second state is degeneracy 2. That is why I put 2 into e to the power minus beta E2. Okay. And finally you will get this answer. I remove this part due to space limitation. I will put e to the power minus beta E1 e to the power minus beta E1 plus 2 into e to the power minus beta E2. Okay, this is a, and you can simplify it this way. It divided by this one, this will divided by this part, divided by this one. It will be 1 and it will be 1 plus 2 e to the power minus beta E2 minus E1. Okay, and according to this question, E1 plus 2 e to the power minus beta E del. Okay, this is the probability in E1 state. Okay, and similarly this is the probability in E1 state. What I am getting, probability of E1 state I am getting 1 plus 2 e to the power minus beta delta. And what is the P2? Whenever I consider P2 state, I have, this is the formula. P2 state is energy E2 is degenerate, so I have to put 2. 2 is the value of ZR. Okay, e to the power minus beta E2 1 plus e to the power minus 1 into e to the power minus beta E1 plus denominator will remain same, always remember, e to the power minus beta E2. Okay, and this answer will be according to the question. If the optional answer is not exact answer, then you have to think that you have to modify the statement so that you can match your answer with the answer given in the question paper. So it will be the probability. You will write the probability. Oh, sorry, 2 is missing. 2 is there. 2, then 2 plus e to the power minus beta E1 minus E2. You can see it. Okay, this is the probability in state 2, in probability in state 1. Or you can write like this. Simply I have modified the answer, but if you confuse, first one answer will be e to the power minus beta E1. Next one into e to the power minus beta E1 plus 2 into e to the power beta E2. This is the answer. And PE2, this will go up. No change. E to the power minus beta E1 plus 2 e to the power minus beta E2, e to the power minus beta E1. And one another things. Okay. Suppose you have find out the probability PE1 state. Then no need to find out PE2 states in the same procedure. You can use another procedure also, because total P1 plus P2 equal to 1. So P2 you can find out 1 minus P1. 1 minus P1, 1 minus P1 means this one e to the power minus beta E2, E1 e to the power minus beta E1 plus 2 e to the power minus beta E2. Okay, it will give e to the power minus beta E1 plus e to the power 2 into e to the power minus beta E2. It will cancel out 2 e to the power minus beta E2. Okay, is it same? 2 is there, 2 is the, this result is same. So you can use these sticks or you can use these sticks. You can verify also, because P1 plus P2 equal to 1. I evaluated P2 from here. This result is similar with this result. Okay, this is a character. This way you have to apply the formula. Next question. Next same question, I modified that question. Question number 2. Question number 2. Question number 2. Same question I modified. Consider a system of n particles. All are fermion, spin half particle, each particle, and this system is affected by magnetic field. Then calculate the probability. And due to application of magnetic field over the particle, it will shift the energy level according to Zeeman effect. You know the Zeeman effect. Zeeman effect is a splitting of energy level due to presence of magnetic field. Or paramagnetism theory, you know the paramagnetism theory. I will also teach you paramagnetism theory. So N particle, this is an spin half particle. This is like that half particles, N particle. And a place in a magnetic field, it will say the energy shifting. See, daily we know this in question, in net gate question, they will give also energy expression E equal to mu dot B. They will like this: if energy in magnetic field is minus mu dot B, okay, of N particle system, all particles spin half and non-iterating. What is the probability of finding particle in two states? So if you remember this formula, or sometimes they will give like this: mu B sigma Z or sigma in polymetics. Polymetics is nothing, just again below polymetics is what? Plus minus 1. So they can give you in terms of vector. I will discuss the question that what type of question may comes once after completing this part. This numerical I have given you only to make you understand what is the probability, what is the partition function. That's all. After finishing that part, all thermodynamic part, I will discuss all the question one by one. Then you will understand more better. So in that case, suppose I am telling the question. In that case, mu dot B means mu B minus cos theta. So mu cos theta equal to minus mu ZB. Okay, is it clear? Yesterday in quantum mechanics I have told you. Okay, mu B cos theta. Mu is not permeability. This is the magnetic moment. So in atomic physics, we know magnetic moment equal to how much? Gs E by twice m S. Okay. So it will be minus Gs. Minus is not there, I think. S means Ms H cross. This is again very good. This is Ms H cross. Twice S. Gs E H cross by twice m Ms. So Ms is a spin. So Ms equal to S means spin. Ms equal to plus m magnetic quantum number. M is M suffix S is the magnetic quantum number. It will take the value of S plus minus S. So S is spin half particle. So Ms will be plus minus half. So this is Bohr's magneton. Gs for spin is equal to 2. This equal to plus minus half mu B. So it will be plus minus mu B. Mu B is suffix, okay? B is suffix. This is Bohr's magneton. So it will give, it is already minus, it is plus minus, so it will be minus plus mu B B. Mu B is a Bohr's magneton and B is the magnetic. Okay. Now what you can understand? What we can understand, whenever placed in a magnetic field, it will split the energy. Suppose in sodium 11, suppose it is Ms value, energy value minus mu B B, one energy, this one MB, this is energy shifting, and energy difference is 2B, 2 mu B B. Okay, according to this question, the energy level will be splitted. That means if the question is like that, then you have to find out the energy value, and you are getting 2 energy value. That means and there is a 2 energy level. Okay. So now question is that this is in previous question we always define energy E1 and E2. Here it's also getting 2 energy level, but value of E1 and E2 is given. Okay, that is the difference. So that is what is the probability, and there is no question of there in the question. They have not talked about degeneracy, so you always consider degeneracy is Gr equal to 1. If the question does not mention the degeneracy, then do not write the Gr value. Gr means 1. Okay. So this is the original formula. Original formula Gr e to the power minus beta Er sum of Gr e to the power minus beta Er. Okay. Now there is no question of degeneracy. Gr equal to 1. You simplify the question. E to the power minus beta Er to the power minus beta ER. Okay, this is the formula. Okay, now in previous problem we have written as E1 and E2. Here we have to put the value. One is mu BB, one suppose minus mu BB. This value we have to put. So you will understand this part again in paramagnetism. When I will teach in paramagnetism, you can easily understand. So what is the probability? First probability. So P E1 state, E1 means this state. E1 means sorry. E1 this one, E2 this one. And this notation is up to you. You can change the notation as per your requirement. Okay, this is E1 means e to the power minus beta E1. Okay, e to the power minus beta E2, E1 plus e to the power minus beta E2. Okay. Now what happened? You have to put this value right. You have to put this value e to the power minus E1 means this one mu B, because B is suffix. Okay, do not confuse with B. Beta. This is not B. This is beta. Beta means 1 by kT. So in order to confusion, I will write kT. Okay, do not confuse. Now e to the power minus mu B by kT. Okay, plus e to the power minus plus mu B by kT. Okay. Now, see, your answer may be like this. If this answer in multiple choice question in the net, the answer may be different. So in that case, suppose this is part, you divide this part. You can do this way, you can do different way also. This part is e to the power x plus e to the power minus x plus e to the power minus x. 1 minus 1 plus e to the power x plus e to the power minus x equal to 2 cos hyperbolic function. You can express in terms of hyperbolic function. Okay, that is up to you, or according to the answer. So I will divide this part. This one, it is 1, it is e to the power mu B by kT. Is it okay? Divide this term 1, it will be 1, it will be reversed plus. Okay, and this you can simplify as 1 plus e to the power del by kT. Why I am writing del? Del is the energy level gap between energy level in magnetic field in this condition is del. Del means 2 mu B beta. So I replace this as beta. This is probability of E1 state. E2 state, similarly E2 state you can calculate. So same thing in numerator, it will say denominator will remain. This is denominator will remain same, numerator will be different. See, only numerator will be different. And if you add up this one, you see this is equal to 1. Okay, this is equal to 1. Now question is now become complicated. Now I modified the question. And one thing that is in probability you have understood right now. So I will give another term. What is a partition function? So this probability we have written is written as suppose GR e to the power minus beta ER for degenerate system. This always remember this is degenerate system. Degenerate system. Sum of GR e to the power minus beta ER. And this is equal to e to the power minus beta ER, e to the power minus beta ER. With this non-degenerate system, non-degenerate. Okay, do not confuse. I mean that is why I am writing again. Non-degenerate is equal to 1. And this term is known as a partition function. Okay, this term is known as partition function Z. So that means what? That means Z equal to summation GR e to the power minus beta ER for degenerate system. Degenerate system. degenerate system, n equal to sum of e to the power minus beta er non-degenerate system, non-degenerate. Okay, do not confuse. This is the partition function. This is for the degenerate system. This is for non-degenerate system. Now, question is that my question is that my question. See, again I modify this partition function Z in our system. This is n particle system. All are spin half particles, 2 energy level E1 and E2. What is a partition function? Partition function all are in non-degenerate. Okay, GR, this is the formula. You can use degenerate formula, non-degenerate formula. It's no problem, but you have to understand what is the basic difference. E to the power minus beta er. Okay, this is sum of all state. GR means it is non-degenerate, so first GR equal to 1, e to the power minus beta E1 plus 1 into e to the power minus beta E2. Okay, better way you can remember one formula, and if it is non-degenerate, GR1, and if it is degenerate, put the value of degeneracy factor. This is a partition function. Partition function you can express, this is e to the power minus beta E1 plus e to the power minus beta E. And you can put this value, e to the power, one is minus mu bb, one is mu bb, mu b, b by kt, one is e to the power minus mu b, b by kt. So this is what? E to the power x, what is the formula? E to the power x plus e to the power minus x equal to 2 cos hyperbolic x. This is the formula you remember. So this equal to 2 cos mu b, b by kt. This is the formula. But what is the basic difference is? Basic difference is, this is the, remember, this is the partition function for single particle. Okay, that is a difference. That's why I am telling you, this is the partition function for single particle. If the partition function for n partition function, for n particle, n number of partition function will be, total partition function will be z to the power, this is suppose 1 n. Okay, z to the power n means it will be 2 cos hyperbolic mu b, b by k. This will to the power n. This is the partition function. Okay, do not confuse. Now again I modify the question. This is the partition function for distinguishable particle. If in the question, if they mention the indistinguishable particle, I have not mentioned here distinguishable, indistinguishable. That is why I have written this formula for indistinguishable particle, distinguishable particle, total partition function equal to z to the power n and divided by factorial n. Okay, this is for indistinguishable. If the in question paper, if it is mentioned the particular indistinguishable and find out the total partition function, then you have to divide it by factorial n. If they in the question paper equation it is not mentioned particular indistinguishable, okay, then you have to write this formula. This is the basic difference. Probably you have understood. If you have any question regarding probability and partition function, you send SMS to me. Okay. Now I am coming back. This is the basic difference. I am coming back. That question comes in a NET exam. Consider a system of E energy. See, same question is comes whatever I have given. Consider a system of n particle. Consider a system of n particle. Each particle has two possible states, and this is n numbers of particle. This is n number of particle, and each particle has two energy level. One energy E is equal to 0. And another E is equal to another level E is greater than 0. Question is like that. Find the probability. Find the find this is question comes in the net exam. Find the P probability at E equal to 0 and E at E. When beta tends to infinity and beta tends to 0. Okay, now condition is applied. This question comes in the net exam. Consider a system of n particle. Okay, and each particle has two energy level. One is E equal to 0 state, one energy level, another is C level. That means this one. This is E equal to 0 energy level, E equal to E, and this is greater than 0. This. Okay. Now question is that find the probability at this level and probability at this level when beta tends to infinity, when beta tends to 0. How can you find out? Easy, very easy. No need to create the confusion. Just remember the probability formula. Probability formula is equal to, the question does not mention degeneracy. Okay, that means degeneracy is equal to 1. Or you can simply write, better way you write all these formulas, general formula. So after that you modify. Okay, this is the formula. If degeneracy, in question they are not talking about energy level degeneracy, then GR equal to 1, you can simplify, write e to the power minus beta ER, e to the power minus beta ER. Okay, no confusion. Now I need the probability E equal to 0 energy. What is the value? Just put e to the power minus 0. Okay, e to the power minus 0 plus e to the power beta E. Is it okay? Equal to 1 plus e to the power minus beta E. This is a one probability. Okay. What I am getting? P is 0 equal to 0. Probability I am getting 1 plus e to the power minus beta E. Okay. This is the probability. Or you can express like that, e to the power minus, 1 plus e to the power minus E by kt. You can express like this also. No problem. Beta equal to 1 by kt. And similarly, is very, you have to do in a first in exam. What this will be what? E to the power minus E by kt. Okay. 1 plus e to the power E by kt. So how can you verify your answer is correct? If you add up, it must be equal to 1. Is it add up? It will be 1. See, 1, it will be 1. And the denominator is same, it will be 1. So your answer is correct. You can verify by yourself whether it is wrong or correct. This is a probability. So what I am getting, see, I am writing here, P0 is, I am getting here 1 plus e to the power minus beta E, this one. And P, this is 0. P is equal to e to the power minus beta E 1 plus e to the power minus beta E. Okay, this is the probability. This is the probability. Now condition is that probability question according to question probability P0 and P when beta tends to infinity. Now case 1, beta tends to infinity means beta equal to what? Beta equal to 1 by kt tends to infinity means what? If infinity comes here, t equal to what? 1 by k infinity equal to 0. Or condition may change. Beta tends to infinity means t tends to 0. Okay? Do not confuse. Both are same. One condition. See, when beta tends to 0 or t tends to 0, then what happens? P0 is equal to 1 plus e to the power minus beta E. You can analyze here also. When beta tends to infinity means what? Beta tends to infinity means t tends to 0. Temperature of the system becomes 0. Beta tends to infinity means 1 plus e to the power minus infinity. E to the power minus infinity is how much? Do not confuse. E to the power minus infinity means 1 by e to the power infinity. Okay. 1 by e to the power infinity means exponential c, e to the power x equal to how much? 1 plus x square, like that. So it will be infinity by infinity plus infinity square factorial 2, like that. It will be always infinity equal to 0. So e to the power minus infinity means always 0. Do not confuse. So it will be 1. Or you can say another way. Suppose if you express this one, 1 plus e to the power minus e by kt. So t tends to infinity, or t tends to beta tends to infinity means t tends to 0. So if you put this value t here, then e by t, anything divided by 0 is what? Infinity. Same thing. So we are getting same equal to 1. Okay. This way you can analyze. See, when a system of 2 energy level, if you are getting probability at particular temperature is P0, at particular temperature means T0 is 1, you are getting 1, then what is the no need to find out the value of P here? It is always P2 is 0. Or you can verify yourself. Because why 0? Because I can guess. Because P0 is 1, so probability is 100%. So rest of the energy level does not have any probability. So you can verify by yourself. You put this value e to the power beta e 1 plus e to the power minus beta. What happened? E to the power infinity 1 plus e to the power minus infinity. It is what? 0. 0 by 1 equal to 0. Now interpretation of this question. See, case 1, interpretation. You try to, you see, one thing, you have to solve the numerical problem. You have to extract information from the solution also. What you are getting the solution? When beta tends to infinity or t tends to 0. How you have? I have already shown you. Okay, beta tends to 0. Beta means 1 by kt. Beta is infinity. T tends to infinity. Is sum. I have already shown you. Then P0 energy level we are getting 1, and PE energy level we are getting 0. Now question. P0 means I have already told what is the probability. Probability formula is I have told you this is the number na. I have already given this formula, you have to apply here. So n0 state n equal to 1. Is it okay? And PE means n e state. N e state divided by n equal to 0. So n e equal to 0. So n not equal to. So in this case, what happened? All particle when t tends to infinity, that particle in excited state is 0, become 0. Just think, when temperature of the system becomes 0, all the particle falls in the ground state, like Bose-Einstein condensation. We will discuss. But this is if it is in case of electron, then we have to follow the Pauli principle. Then there will be different condition we have to impose on the question. Okay, this is finding the particle. Probability of finding the particle in a ground state is maximum is 100%. All particle at temperature T become 0, it will fall on the ground state. But whether it fall on the ground state, how it is fall, that will follow according to the Fermi statistics and following the Pauli principle. That is the difference. This is a statistical means and mathematical interpretation. Physical interpretation from mathematical equation. Okay, case 1. Case 2. You got it? Case 2. When beta tends to 0. Beta tends to 0 means beta EC. Beta tends to 0 means 1 by kt equal to 0. Kt equal to 0 means t equal to how much? 1 by k0. K0 means 1 by 0. So beta tends to 0 means t tends to infinity. In question they can give you either beta tends to 0 or t tends to infinity. Okay. Then under this condition, what happened? P0 state, 0 state is the probability 1 plus e to the power minus beta e. Okay, beta is 0. Beta is 0 means this is 0, or you can see here also 1 plus e to the power minus e by k. T is infinity. Any number divided by infinity becomes 0. Okay, you can see here also 1 plus e to the power minus 0. You can see same condition. You can see here 1 plus e to the power minus e by infinity. Any number divided by infinity is 0. So it is what? 2. This is what? Any number divided, sorry, okay. Any number divided by infinity becomes 0. So it will be 1 plus. This one e to the power 0 means half. It will be 2. Same thing. You can interpret it from here also. You can interpret it from here also. But we are getting half. And if we are getting half, it will be same. P equal to e to the power beta e 1 plus e to the power minus beta e. So it will be e to the power 0 1 plus e to the power 0 equal to half. See. So at high temperature, the number of particles in ground state and upper energy state equally distributed. Probability disease means what? N E by N. This is what? This is also known fraction of particle occupied in upper state. This half means 50%. 50%. And here in ground state, so at very high temperature, fraction of particle in ground state is 50%. Okay, this condition you have to find out in an exam. And one thing whenever we do the calculation of microstate calculation entropy, you probably you have find this formula S equal to entropy A ln omega. Omega is the number of microstate. Okay, number of microstate in spin half particle in two level system. What happen at high temperature? When temperature is very high, what about only case 2? Then what happen? Number of microstate for each particle is equal to 2. Is it okay? 2. One is upper state, one is down state. Number of microstate means possible state. So there is the upper excited state and ground state. There is 2 state. So now, 2 level system. Why it is 2 state? Because it is spin half particle. So you have already remembered and LS notation. Y says plus 1 LJ. This formula, LS notation, you remember this formula. Okay, this is number of microstate equal to twice as plus 1 state. Always remember. So why it is 2? You see, number of microstate in spin particle is twice as plus 1 state. Now in this problem, we are suppose in previous problem we are considering system of n electron. So electron is spin half particle. So it will be 2 into 2 plus 1 equal to 2. Number of microstate. In previous example in magnetic field we have discussed there is a possible energy level. This possible energy level is known as a microstate. So there is 2 microstate. So for single particle. For n particle, number of microstate will be 2 to the by n. Okay. So entropy in that case, entropy K ln omega is K ln 2 to the by n K ln 2. Okay. This question often comes in a gate exam. But suppose particle is not spin half particle. Particle is fermion, but not it is electron. Suppose particle has a spin 3 by 2. 3 by 2 is also fermion. Spin is 3 by 2. Then what are the total number of microstate will be? Number of microstate will be, how can you define? This is the formula, always remember. This is not written in a book. Not in a Pathria book, but it is this formula is I have compared with a spectroscopy term in order to remember, or it is already given in a spectroscopy book, LS notation. So in spin half particle it will be how much? 2 into 3 by 2 plus 1, 2 to cancel, number of state will be 4. So how 4? S is half, MS is how much? Minus S to plus S, 3 by 2 half, like this now. In atomic physics. ms value is how much? Minus s2 plus s. 3 by 2 half and minus half. See, in atomic physics, whenever s equal to 3 by 2, ms value is how much? Minus s2 plus s. That means what? 3 by 2 half minus half 3, minus 3 by 2. How many microstate are available? 1, 2, 3, 4. Okay, similarly in statistics also we are getting 4 microstate. Okay, entropy you can calculate. Entropy is in for this type of particle, total number of microstate will be 3 to the by n. Okay, for this type of particle. First you find out the microstate, from the spin. Okay, then entropy equal to k ln omega. This is the entropy formula. So k ln 3 to the by n and k ln 3. So this question is also comes in a GATE exam. Students often get confused. Sometimes it is ln2, sometimes it is ln3. Why? Because of this. But this is not clearly mentioned in Pathria book. Okay, I compare this in order to remember this number of microstate. I derived this formula from atomic physics. Atomic physics we have already understood LS notation, Russell-Sanders notation. From that notation, I formally written number of microstate process plus 1 for single particle. N particle to the power, that is 4. Okay. And okay, thank you. I am not going to teach you more today. This is the always remember. So finally, I want to give you a general formula so that you can remember probability. Again, I am giving the formula so that you never confuse. GR e to the power minus beta ER. GR e to the power minus beta ER. For degenerate system. Huh? Okay? Degenerate system. I'm again giving you so that you never confuse and never do wrong in the exam. This will equal to e to the minus beta ER, e to the minus beta ER for non-degenerate system. Degenerate system. Okay. Now partition function for single particle. Okay. Partition function for single particle. GR this part e to the power minus beta ER for degenerate system. Equal to e to the power minus beta ER for non-degenerate system. Okay. This is degenerate, this is non-degenerate. This is degenerate, this is non-degenerate. But this is partition function for a single particle. Now total partition function z t equal to z to the power n. For remember this z to the power n means how much? For I am writing only non-degenerate system. Okay, degenerate system means here you have to put e to the minus beta ER to the power n. This is for distinguishable particle. Okay, and this is zt equal to z to the power n factorial n is there. This is a total partition function. Okay, and this is partition function of single particle to the power n. In this case, all will remain same. Beta ER to the power n factorial. Okay, this is indistinguishable particles. Okay, this is the formula I have already discussed. We'll discuss again after that, because one thing last, Partition function is the statistical function. It represents number of microstate, and from this partition function we can evaluate all thermodynamical parameters: temperature, pressure, volume, chemical potential, pressure, mean energy, specific energy. We can calculate everything. That is why we have to understand probability, two-term probability partition. Next class we will going to discuss the mean energy. Okay, thank you.